I'm Anil Kumar. We're discussing polynomial functions. In this particular video, we'll talk about their symmetry. A polynomial function could have even symmetry or odd symmetry. To give you an idea about it, what is even symmetry? Let me write down. Even symmetry will mean that it is symmetric about y-axis. Is it okay? The other way to figure out is that the value of the function f of minus x is equals to f of x. That is when the function has even symmetry. Now, how about odd symmetry? Well, let me write here. Odd symmetry is it is symmetric about a point, and this point is no other point but origin, that is 0, 0. Is it okay? And also algebraically we can find the value of f of minus x, and if it is equals to minus of fx, then the function has odd symmetry. Is it okay? Okay, so that's the definition. Now based on this definition, the question for you is, we are given two graphs, A and B. Explain if they have any symmetry. These graphs are of polynomials, as you can see. Continuous curves without corners. C and D, we are given you two equations. F of x equals to x squared plus 2. D is f of x equals to x cubed minus x plus 2. You have to find whether these functions what kind of symmetry do these functions have, right? So that's the question for you. You can always pause the video and answer the question. Here is my solution. The very first one is an odd degree polynomial going through origin as shown here, and it has odd symmetry. See, if I draw a line here, every point will have a symmetric point image on the other side. So this one has odd symmetry since it is symmetric about the point origin. Do you see that? And here this function is symmetric about y-axis. That is to say, we have a mirror image, right? So this is even symmetry. Is it okay? So we have odd symmetry for A. Let me write it in short form. And even for part B. Now, how do you do when the equations are given to you? As I said, we have to find f of minus x. So for C, what is f of minus x? Replace x with minus x. We get minus x squared plus 2. That is to say, x squared plus 2. Now, x squared plus 2 is same as equal to f of x, right? So f of minus x is equal to, minus x is equals to f of x, and therefore this leads to even symmetry, correct? So this function is even. It has even symmetry. How about the next one? So let's again find what is f of minus x. Replace x with minus x. We get minus x cubed minus of minus x plus 2. That is minus x cubed plus x plus 2. Now this is not equal to minus of f of x, and therefore it is not odd, right? We were expecting it to be odd since we had one odd degree, but 2 has even degree, and that makes this function neither, right? So neither even nor odd for this particular function, right? So we could find symmetry of a polynomial function based on the graph. If it is symmetric about origin, then the polynomial will have odd symmetry. And if the graph of the function is symmetric about y-axis, then that polynomial function has even symmetry. If we are given an algebraic equation, then we can try to find the value of f of minus x if f of minus x is equals to f of x, then the function has even symmetry, as is the case with part C. If f of minus x is not equal to f of x, then it doesn't have even symmetry. It could have odd symmetry if f of minus x is equals to minus of f of x. But if both are not true, then the function does not have even or odd symmetry. So part D doesn't have either even or odd symmetry, so it's neither of them. So that's what we conclude from this video. I hope it helps. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.